All right, in this video, we are going to solve this exponential equation, 3 to the minus 3x plus 2 equals 103. Okay, so what we are going to do is to put this exponential equation, it's in this exponential form, right? B to the y equals x. And we are going to convert it over to logarithmic form. If you haven't watched any of the previous videos about converting back and forth between these two forms, then you need to go back and watch those videos. Okay, so here's what we're going to do. We are in exponential form, or this equation, right, is in this exponential form here. And we can see that the log base, the base of the exponential function b, right, is going to be the base of the log over here. So when we go to convert this equation, right, we're going to get log base 3 of x, okay? Well, the x here, if we look in the exponential form, right, is the expression that is by itself, right, on the other side of the equal sign from the exponential, right? So in that case, that's this 103, okay? All right, and then the exponent in the exponential form goes by itself, right, on the opposite side of the log. So in this case, the exponent is minus 3x plus 2. Okay. Okay, so now that we have converted this over into the logarithmic form, then what we're going to do is to solve for x, get x by itself on one side of the equation. The first thing that we are going to do is to add or subtract, right? So that every term with an x is on one side, every term without the x is on the other side. All right, so I'm going to subtract 2 from both sides. So over on the left side, I'm going to get log base 3 of 103 minus 2 equals minus 3x. So do not, I'll see a lot of people try to combine this 2 with this 103 here. You cannot do that because this 103 is inside the logarithm. And unless you're using one of the 3 properties of logarithms that we talked about, you shouldn't be messing with the inside of these logarithms. It just doesn't, it doesn't work that way. Okay, so you got to be very careful about that. Unless you're using one of the 3 properties, right? The power rule for logs, or the quotient rule for logs, or the power product rule for logs, then you shouldn't be combining things that are inside the log with things that are outside of the log. Okay. All right, so now we can see that we have every term with an x on one side, every term without an x is on the other side, and so then what we can do is to divide both sides by a negative 3. So I'm going to take this entire side, divide by negative 3. So our answer here is log base 3 of 103 minus 2 divided by negative 3. Equals x. Okay. All right, and so we've solved for x, and so this is our answer here. Now, the only issue, right, is that, if you need a decimal answer to this, right, then the problem is going to be when you try to plug log base 3 into your calculator, there is no log base 3, right? So what you'll have to do, just for instance, Desmos, if I go to Desmos, right, and do log base 3 of 103 minus 2, all of that divided by negative 3, right, then I'll get my answer, minus 0.7396 to 4 decimal places, right? So if you have Desmos, then you can plug it in like that. If you do not have Desmos, right, then you can use the change of base formula to plug that in using this approach. So if you do that, then this log base 3 of 103 would become ln of 103 divided by ln3, right? Using the change of base formula. So if you're using your calculator to get a decimal approximation, that's one way you can do that. All right, and because your calculator has an ln button, right, then you can use that to do that. Let's see if I can pull that up so where you guys can see how it's punched in. Now your calculator, might not be the same as mine, but at least you can kind of get an idea. Okay, so it's ln 103 divided by ln 3 minus 2, and then divided by minus 3. All right, we should get that same value that we got over here, right, for in Desmos. Okay. All right, the way I've showed you here is not the only way to solve this, right? You can take the ln of both sides, right, and then solve that way. The algebra, right, will be slightly more complicated than what we have here, but you will end up with a similar answer to the answer that we've obtained.